Some more problems, children. Find the equation of the plane passing through the point and perpendicular to each of the planes. Find the equation of the plane passing through a single point, and that plane is perpendicular to two other planes. So first we write what is the required plane. The required plane passing through a single point. And what is the equation of a plane passing through a single point? Cartesian form we can write. Equation of the required plane. Equation of the required plane is equal to, the equation is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the equation of a plane passing through a single point. Then point we can substitute x1, y1, z1. Therefore, a into x plus 1 plus b into y minus 3 plus c into z minus 2 equal to 0. Okay, and we need a, b and c. Then only the equation we get. A, b and c means that represent normal to the plane, perpendicular to the plane. But that is not given in the question. Instead of that, this plane is perpendicular to two other planes. This plane is perpendicular to other planes. So for this plane we have the normal, and for this plane the normal is like this. So they are perpendicular. If two planes are perpendicular, their normals are also perpendicular. So here the direction ratios of the normal of this plane A, B and C, and this A, B and C, this is, I put the number, okay, and 1 is perpendicular to, we'll write the next equation, x plus 2y plus 3z equal to 5, that's the second plane, and the third plane is 3x plus 3y plus z is equal to 0. So what is given? 1 is perpendicular to 2, 1 is perpendicular to 3 also. If two planes are perpendicular, their normals also perpendicular. So take the direction ratios of normal A, B and C. Here the number, coefficient 1, 2 and 3. The dot product equal to 0. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. That condition we have to write. So since plane 1 is perpendicular to plane 2, therefore we can write A into 1, okay, A into 1 plus B into 2 plus C into 3 equal to 0. That is A1, A2 plus B1, B2 plus C1, C2 equal to 0. Or we can write A plus 2B plus 3C is equal to 0. Okay. The same way we can write 1 and 3 are also perpendicular. Since 1 is perpendicular to 1 is perpendicular. One is perpendicular to 3, therefore A into is here, its coefficient 3. A into 3 plus B into 3 plus C into 1 is equal to 0. Or what is it? 3A plus 3B plus C is equal to 0. Okay. So equation 4 and 5. Now we have to solve equation 4 and 5. We have 3 unknowns but 2 equations. So we can use the cross multiplication method. Do you know that? A plus 2B plus 3C is equal to 0. 3A plus 3B plus C is equal to 0. Okay. So you have to do like this. A by. We have to find A, B and C. So first write A. Then don't take this A part. Take these two. Its coefficients are 2, 3, 3, 1. like determinant, just cross multiply. 2 into 1 minus 2 into 1 minus 3 into 3. Now put equal and write the next unknown, that is b. Then here don't take this b portion. A and C you have to take, that coefficients are 1, 3 and 3, 1. Okay. Then cross multiply, but usually we cross multiply like this, but this is second, so you have to do in the reverse order. First you do 3 into 3 minus 1 into 1, or you can put minus sign like determinant. Second number you have to put negative, that way also you can do. Then the third is C by C portion don't take, here 1, 2, 3, 3. 1, 2, 3, 3. Just cross multiply. 3 minus 3 into 1 minus 3 into 2. Then put equal to some lambda. So A by minus 7, B by 8, C by minus 3 is equal to lambda. Or A is equal to minus 7 lambda, B is equal to 8 lambda, C is equal to minus 3 lambda. Now substitute, where we substitute, which is the required equation, this 1. Substitute in 1. Okay. So equation 1 becomes minus 7 lambda into x plus 1 plus 8 lambda into y minus 3 minus 3 lambda into z minus 2 equal to 0. Now lambda you can take outside. Okay. Minus 7x minus 7 plus 8y minus 24 minus 3z plus 6 equal to 0. Lambda take to right hand side, 0 by lambda becomes 0. So you have to write minus 7x plus 8y minus 3z. Then minus 24 and 7 is minus 31 and 6 is minus 25 equal to 0. Or multiply by negative, 7x minus 8y plus 3z plus 25 is equal to 0. That way also you can write. Okay. The next one, find the vector equation of the line passing through. Vector equation of the line passing through a single point and parallel to the planes. Two planes are kept. So we have to write vector equation of the line passing through a single point. So what is the required equation of the line? Required equation of the line is vector r is equal to vector a plus lambda vector b. A means the line passing through the point, its position vector, and b vector is the parallel vector. So that vector is not given, A is given, the point I plus 2j plus 3k. Okay, plus lambda into b vector. That is not given. B vector means I part, j part, k part. That is not given. But what is given? This line is parallel to the planes. So line parallel to the plane means B and normal are perpendicular. The condition is like that. Line parallel to the plane means the parallel vector and the normal vector are perpendicular. So we can multiply. Perpendicular means always the condition A1, A2 dot product equal to 0. That's one. So normal vector, this bracket gives the normal vector of the first plane. This is the normal vector of the second plane. And B vector we can write as its direction ratios. Usually the denominator A, B, C. X minus x1 by A, y minus y1 by B, z minus z1 by C. In that way we have to write. Okay. So I put this equation 1. Direction ratios of, let direction ratios of B vector. B, small letter A, B, C. For normal we use capital letters. Okay. Then this first is parallel to the first plane. Plane I am writing vector r dot I minus j plus 2k is equal to 5. This is second equation. And the second plane is k cap is equal to 6. Okay. So what is given is 1 is parallel to 2, since 1 means line parallel to the plane 2. So we can take the dot product, or A into 1 minus B into 1 plus C into 2 equal to 0. Or we can write A minus B plus 2C is equal to 0. Equation 4. Now again, since 1 is parallel to 3, which is 3. Again multiply A into 3 plus B into 1 plus C into 1 is equal to 0. So 3A plus B plus C is equal to 0. So now we have to solve 4 and 5, 2 equations and 3 unknowns. So A by, okay, so don't take this A part, B and C is coefficient you have to take, then cross multiply. Minus 1 minus 2 becomes minus 3. Then equal to B by coefficient of A, coefficients of C, cross multiply, but second part is first this second. So 6 minus 1 is 5. Now C by coefficient of A and B, 3 and 1. Cross multiply 1 plus 3, that is 4. Equal to lambda or mu, whatever you can give. Now what is A? So A is equal to minus 3 lambda, B is equal to 5 lambda and C is equal to 4 lambda. Now where we substitute? In the required plane. There lambda is already there, so instead of lambda you can give some mu. Okay. Or without mu you can write. So the equation, therefore required equation is equal to vector r, vector equation only we have to write. Vector r is equal to I cap plus 2j cap plus 3k cap plus lambda into this mu you can take outside. Lambda and mu are real numbers. So instead of lambda into mu you can write any other real number, no problem. Otherwise you can neglect this mu and just write the coefficient part. Minus 3I cap plus 5j cap plus 4k cap. Vector B means there are I, j, k part. That's why we write like this. Okay. So this is the required equation. Okay. Third one. Find the vector equation of the line passing through point and perpendicular to two lines. Find the vector equation of the line passing through a single point. So first we can write the required equation. Required equation of the line. Vector equation passing through a single point. So A plus lambda B, that's the required form. A is given, therefore vector R is equal to I plus 2j minus 4k plus lambda B. We don't know B, we have to find. So for that it is given this line perpendicular to two other lines. So two lines are perpendicular, then A1 A2 plus B1 B2 plus C1 C2 equal to 0. That condition we can apply. So the second line is x minus 8 by 3. Z minus 10 by 7. This equation 2. And third one, y minus 29 by 8. Z minus 5 by minus 5. So 1 is perpendicular to 2. Again we can write the direction ratios of B, then only we can multiply. So let ABC be the direction ratios of vector B. The previous one also I wrote like that. Okay. Since 1, the first line is perpendicular to second line, therefore what we can write, a into 3, the denominator part. This 8, 19, 10 and 15, 29, 5 means the coordinates, the line passing through the point, that we won't take that part, we take only the denominator portion, that is the parallel vector. Okay. So a into 3 or 3a plus b into minus 16 plus c into 7 is equal to 0. Now the second one, a into 3, since the lines are perpendicular, that's why we use this condition. Then b into 8, okay, 8b minus 5c is equal to 0. Now solve 4 and 5. So a by determinant minus 16, 7, 8 minus 5. 16 into 5 is 80, 80 minus 56. So it is 24. Now b by 3, 7, 3 minus 5. So minus 15, sorry, 21 first we have to write, plus 15, that's equal to 36. Then c by 3 minus 16, 3, 8. 24 plus 48, 72 equal to lambda. If there is common factor, you can divide. It's multiple of 12, a by 3, 12 into 12, 6 are 72. So a by 2, b by 3, c by 6 is equal to lambda, or a is equal to 2 lambda. Instead of lambda, if you want to write mu, 2 mu, then b is equal to 3 mu, c is equal to 6. Now substitute in the first equation. First equation is the required equation. Therefore, required equation is vector r is equal to I cap plus 2j cap minus 4k cap plus lambda into 2i plus 3j plus 6k. Okay. And one more question, children. This is an important question. Find the coordinates of the foot of the perpendicular and the length of the perpendicular drawn from the point 5, 4, 2 to the line. Also find the image of P in this line. Find the coordinates of the foot of the perpendicular drawn from the point to the line. So point P, from P draw one perpendicular to the line. Line is given. So let Q be the foot of the perpendicular. So we have to find the coordinates of foot of the perpendicular, length of the perpendicular, that means PQ we have to find. Also find the image of P. So you have to extend this to R. What is R? Coordinates we have to find. So first line's equation is given. This is line L. Okay, we have to convert to Cartesian form. So vector r is equal to minus I cap plus 3j cap plus k cap plus lambda into 2i plus 3j cap minus k cap. This is a given line. So when we convert to Cartesian form, r is xi plus yj plus zk. Take to this first bracket. This part you have to take to the left side. Then divide by these numbers. Then put equal to lambda. So I am writing in one step. X take to this side. So x plus 1 by 2. That's equal to lambda. Equal to y minus 3 by 3 equal to lambda. Z minus 1. This part you have to take to left side. So z minus 1 by minus 1 is equal to lambda. Okay. Now we have to find foot of the perpendicular. So let Q alpha, beta, gamma be the foot of the perpendicular. Okay. So this alpha, beta, gamma lies on this line. So we can give alpha, beta, gamma for this x, y, z. Therefore, alpha plus 1 by 2 is equal to beta minus 3 by 3 is equal to gamma minus 1 by minus 1 is equal to lambda. Or which implies what is alpha? 2 lambda minus 1. Okay. And beta is equal to 3 lambda plus 3 and gamma is equal to minus lambda plus 1. So we get coordinates in terms of lambda, that is Q. Now how we get lambda? For that, for this line, the second bracket means its parallel vector. So there is a parallel vector B, that B is the second bracket, 2i cap plus 3j cap plus minus k cap. So this B vector and PQ are perpendicular. Since PQ is perpendicular to this B vector, then the condition perpendicularity A1, A2 plus B1, B2 plus C1, C2 equal to 0, that is direction ratios product equal to 0. So we have to find the direction ratios of line PQ. Direction ratios of PQ. Direction ratios of PQ. P is given. What is P? 5, 4, 2. Okay. P is 5, 4, 2 and alpha, beta, gamma this one. So how to find direction ratios of PQ? We have to subtract x2 minus x1, y2 minus y1, z2 minus z1. So 2 lambda minus 1 minus 5, 3 lambda plus 3 minus 4, minus lambda plus 1 minus 2, or 2 lambda minus 6, 3 lambda minus 1 minus lambda minus 1. These are the direction ratios of line PQ. Since PQ is perpendicular to the parallel vector B, then we can multiply this into the corresponding ij part, that is 2 lambda minus 6 into 2 plus 3 lambda minus 1 into 3 plus minus lambda minus 1 into minus 1 is equal to 0. Then open the bracket. 4 lambda minus 12 plus 9 lambda minus 3 plus lambda plus 1 is equal to 0. 14 lambda is equal to minus 15. So it is 14. So lambda is equal to 1. So what is alpha? 2 into 1 minus 1 is 1. Beta is equal to 6 and gamma is equal to 0. So foot of the perpendicular. Foot of the perpendicular, it's equal to 160. Okay. Now we have to find length of the perpendicular. length of the perpendicular. That means PQ. We have to find PQ. What about PQ? The distance between P and Q. What is P? 542. Okay, 542 and this point. 542 and this point. What is the distance? So 5 minus 1 whole square plus 4 minus 6 whole square plus 2 minus 0 whole square. That's equal to 4 square plus minus 2 square plus 2 square. 16 plus 4, 20, root 24. Okay, or you can reduce 4 into 6 to root 6 unit. Now we have to find image. That also we have to find. Look here. Also find the image of P in this line. So here I have extended to R. Let R be the image. ABC or any other letter you can use. This is the image. So this PQ and QR must be equal, or Q is the midpoint of PR. That result we have to apply. So let R ABC be the image of P. Okay. So A plus 5 by 2 is equal to PQR. Here ABC 542 and Q, coordinates of Q are 160. Apply midpoint formula. So A plus 5 by 2 is 1, comma B plus 4 by 2 is 6 and C plus 2 by 2 is 0. So what is ABC? A is equal to minus 3, B is equal to 8 and C is equal to minus 2. So image minus 3, 8,